Okay, an air-filled 50 microfarad capacitor has a voltage of 10 volt. An insulator with a dielectric constant of 4.0 is inserted between the metal plates. Okay, calculate the new voltage across a capacitor, the charge stored on the capacitor, where the energy stored in the capacitor increase, decrease, or stay the same. Good. Okay, look at this condition. Okay, these questions. Is it talking about the capacitor remains connected with battery or disconnected with battery? Does it mention anything about battery? No, isn't it? There's no battery involved here. No battery. Yeah, no battery involved. So this capacitor actually is disconnected from battery. This is the first thing we should know. Okay, it's actually the first thing we should know is this capacitor is disconnected from battery. This is the first important thing we must know. Okay, disconnected from battery. So we must say the charge is constant. We learn about there's two conditions. Either is disconnected from battery or battery remains connected. If battery disconnected, that means the charge is constant because the charge remains inside the capacitor, cannot flow anywhere. Whereas if battery remains connected, the voltage is constant because it remains connected to the battery. It must have the same voltage as the battery. All right. Voltage is constant. But since here this question doesn't mention anything about battery, that means this capacitor is not connected to battery. It's not connected to battery. So the battery is disconnected. So we can say the charge is constant. This is the I think this is the first thing you should know for this question. Okay, the charge is constant. Okay, what I can say is this capacitor is already charged. Yeah, it's already charged because it already have voltage. You see that? It's already this already charged capacitor. Yeah, this is already a charge. Already charged capacitor. So because it has initial voltage, it already has initial voltage, 10 volt. Okay, and anyway, how much charge is it? We can calculate using formula Q equal to CV. How much charge? Q equal to CV. We can calculate the charge. This is already the initial voltage. We can say put it as V1. Yeah. V1 initial voltage, and this is the capacitance. See, microfarad. You have to change to SI unit, and then here's the insulator. This insulator is a dielectric. Okay, that means you put the dielectric in between the two plates. Initially it is a vacuum. Initially it is vacuum. Air filled, that means without dielectric lah. Without dielectric. Without dielectric. Then you put a dielectric inside. Okay, with dielectric constant. Dielectric constant 4.0. Dielectric constant is actually ER. It's not E. Remember, it's not E. It's ER only. Yeah. Dielectric constant is ER, or we can put as K. Remember the definitions. Okay. Dielectric constant is ER, or K. ER. Dielectric constant, or we call it relative permittivity. Is the ER. It's not the E. E is permittivity of dielectric material. It's not the E here. It's just the ER. No. So remember, dielectric constant is ER, not E. Okay. Okay. So what I can say is we have a capacitor. In short, we have a capacitor initially charged. Initially is already charged. Okay. It has initial. It has the charge. Already has a charge Q. Okay. and then which is constant, yeah, because there's no battery. It is not connected to anything. All right, disconnected from battery. And then it has initial voltage of 10 volt. After that, you put dielectric in between the two plates. Okay, then you put a dielectric. Let me draw. Yeah, and then you put dielectric in between. Okay, but the charge is still constant, but because it's disconnected from battery. Okay, but then it will have a different voltage. Yeah, we don't know what's the voltage. It will have different voltage. All right, so that's it. Okay, it put the dielectric in between with ER equal to 4.0. Yeah, ER equal to 4. Okay, so let's calculate the new voltage V2, yeah, across the capacitor. So how to do these questions? Okay, what I can say is okay, since this capacitor is not connected to battery, yeah, so the charge is constant, we can find the charge first. Okay, find the charge for initial charge and final charge should be the same. Yeah, should be the same because not connected to battery. Okay, we find the charge first. Yeah, we already have the capacitance here, and we already have the voltage. Okay, initial voltage. Capacitance is also capacitance is not the same lah. What I can say is the capacitance is not the same. Let me put it over here also. Okay, this one has capacitance 1, okay, which is 50 microfarad. Like this type of question, you should draw out the picture. Then you should know there is two conditions: initial condition and final condition. All right, because one is air filled without dielectric, one is with dielectric. Okay. All right. So this one you can put as C2. Okay. C2. All right. Okay. So we can calculate first the okay. Okay. Since we can write this one without dielectric. This one without dielectric, we can put this as C0. All right. Because it's let me write it down. This one is without dielectric, and this one is with. Now you insert a dielectric. This one is with dielectric. So this one is C2 is with dielectric. We can put this as ERC0, isn't it? ERC0. And since C0 is C1, we can write this as ERC1 also lah. You can write this as ERC1. Okay. Because we know about this, right? If we're with dielectric, the C is actually ERC0. Okay, if with dielectric, the C is ERC0. Okay, let's calculate first the C2. Okay, so C2 will be this C2 will be okay, let's rub this. C2 will be C1. Okay, ERC1. So what is ER? ER is 4. ER is 4, and then C1 is 50 microfarad. Okay, so this one you have 200 microfarad. This is the capacitance with dielectric. This one is for this second condition. Okay, the capacitance for dielectric, the capacitance for the capacitor with dielectric, 200 microfarad. Okay, after that, okay, we got already capacitance for capacitor with dielectric, and then we also can calculate the charge. Yeah, charge. We can calculate the charge. This Q, Q equal to C. Q equal to C1, Q equal to C1 V1, isn't it? Q equal to C1 V1, which is 50 microfarad multiplied by V1 is 10 volt. So we have 500 microcoulomb. Remember, this one is microcoulomb, it's not coulomb, because we have microfarad. Because right here, I want to write it down. Here is micro, so that's why here also micro. Okay, all right. So this one is constant. The charge is constant because this capacitor is not connected to battery, So the charge is always remain inside the capacitor. So this 500 microcoulomb is constant even after you insert the dielectric. Even after you insert dielectric, the charge is still 500 microcoulomb on the capacitor. So I can write this as the charge here is 500 microcoulomb, initial and final. Okay. All right. Okay, so I got the capacitance ready with without dielectric 50. I also have the capacitance with dielectric 200 microfarad. Okay, and the charge also I got ready. Question A, find the new voltage across the capacitor. So how to find the new voltage here? So we don't know the V2. We want to find V2. Okay, the new voltage. That means we need to find V2. Okay, so how to find the V2? Okay, so V2, we have the C2 already. C2 we have. We also have the charge, isn't it? So we can do it. So we can do this way. Q2, we can just put Q because charge is constant, equal to C2 V2, Q equal to CV, right? We already have the C2. We also have the Q already, 500 microfarad, because coulomb. Sorry, this one is coulomb. Sorry, mistake. This is coulomb. 500 microcoulomb. The charge, yeah. So initial charge and final charge is constant, yeah, because disconnect from battery. Okay, so so this 500 microcoulomb is the same as the charge here. Okay, so I can put this one also as I can put this one as 500 microcoulomb. Okay, and then capacitance is capacitor I got just now is 200 microfarad. 200 microfarad. Okay, so multiply by V2. Okay, now micro and micro can cancel off. Yeah, micro is exponent -6. 500 divided by 200. So the voltage 2 is 2.5 volt. So I got already the answer. Is that correct? 2.5 volt? That's right, 2.5 volt. So I can write this 2.5 volt over here, yeah, at the diagram, so that I can, you see, I like to put two column. Okay, so to separate the data. So this is the first condition. The first condition without dielectric. This is the second condition without dielectric. So I can all the information are all the informations is very systematic. Already have two columns, yeah. All the information without dielectric, all the information with dielectric. So 2.5 volt I just put over here, okay, for reference later on. Okay, C2 also I got just now, isn't it? C2 also I got just now, 200 microfarad. I can put over here also. I already calculated is 200 microfarad for this one. Okay, this one I have C1 50 microfarad. 50 microfarad. Here is 50 microfarad. Here is 200 microfarad. Okay. Now, okay, next I want to calculate the charge stored on the capacitor. Charge stored on the capacitor. So what I can say is, you want to find Q. Q is, you can say Q1 is equal to Q2 is equal to Q lah. It's constant. The charge is constant because it's disconnected from battery. All right. So what I can say, the charge is, what is the charge? 500 microfarad. Question B. Charge stored on the new charge stored B. What I can say, Q2 is equal to Q lah. Yeah, is 500 microcoulomb. Is 500 microcoulomb. So the charge is constant. The charge is constant all the time. Okay, so the answer is correct, 500 microcoulomb. Okay, now C, will the energy stored in the capacitor increase, decrease, or stay the same? Good. So this one, find the energy stored in capacitor. That means you want to find the U. How is U2 compare to U1? Okay, how is U2 compared to U1? Is it the same or different? Compared to U1. So how is the energy stored? Okay, so we need to find out. Question C. Okay, question C. Right over here, C. Yeah. Okay, U1 is equal to, I can calculate. Okay, what's the U formula? What is the U formula? U formula, we have half QV, half CV square, half Q square over C. So which formula do we use? Okay, bear in mind, this question is Q constant. Disconnect from battery, the charge is constant. So if charge is constant, we normally use a formula which has the charge. So we only use half QV or half Q square over C. Half QV or half Q square over C, because we want to have one variable as a constant. So when the other variable changes, we can know the changes in the U. You understand? We can know the changes in the U. So we only use half QV or half Q square over C. So we can see that. Okay, maybe I can put it over here. Put it over here. Right? Make it black color. Okay. So since the charge is constant, so we only use half QV or half Q square over C. Try not to use half CV square, because if you use half CV square, then you have two variable change. Then overall you have three variable changes. C changes, V changes, then U also changes. So we don't know how is the U changes really. Okay, we don't know how the U changes really, because we have two variable changes. Right now we use half QV or half Q square over C. So we can know Q is constant always. Q is always constant. Q is always constant. So there's only one variable changes, either V or C. Yeah, changes. So we can know what's the changes in the U. You understand? So there are three formula here. We only use this half QV or half Q square over C, because there is a Q there. We know that is always constant. Okay, now will the energy increase, decrease, or stay the same? So we should compare. Okay, so Q is constant because the charge is disconnected from battery. But then if you look at the look at the first equation, half QV. If you use a half QV, look at what happened to the voltage. What happened to the voltage? The voltage decrease. Can you see that? The voltage decrease from 10 volt, yeah, from without dielectric, then you insert dielectric, the voltage decrease from 10 volt become 2.5 volt. From 10 volt become 2.5 volt. So that means the voltage decrease. So the charge torque decrease. I can predict that the charge torque decrease because the voltage decrease. Or if you want to use the third one, also can. Yeah, if you want to use the third one, also can. Look at what happened to the capacitance. Capacitance between C1. C1 is also the C0. Yeah, because C1 is without dielectric, so we call it as C0. Okay. All right. Look at between C1 and C2. Which one higher? Of course, the one inserted with dielectric is higher. Yeah, higher capacitance or higher ability to store charge. So after you insert a dielectric, the capacitance increase. You see, from 50 become 200 microfarad. So the capacitance increase from C1 50 microfarad increase to 200 microfarad. So the capacitance increase. So capacitance increase. Capacitance increase. According to this formula, capacitance increase. So we can know the energy stored also decrease. So you see, we have two formula we can use. We can either use this one or we can use this one. So both formula also tell us the energy stored in capacitor has decreased after you insert the dielectric. So will the energy stored increase, decrease, or stay the same? I can say energy stored decrease. Energy stored decreases. Okay, energy stored is the U. Or just put as U decreases. Okay, after you insert the dielectric, energy stored decrease. Okay, so but you when you answer this question, after you mention energy stored decrease, you must show the proof. You can either show this formula or this formula. This is the proof. You always prove by formula. Say which one is constant. The charge is constant, but the voltage decrease, so the energy stored decrease. You should give a formula as a proof, understand? Or you also can calculate the value to show the real proof. Okay, let us calculate the value and see and compare. Maybe we use the half QV. Okay, half QV. So okay, let us use the formula. Or you want to use a half Q squared over C to calculate the value of energy stored, also can. So you have two choices. You want to use number 1 or number 2, also can. All right. So let us calculate the value. U1 is equal to half Q V1. Q is constant. Q is constant. Only the voltage changes. For the second condition with dielectric, then that one is half QV2. Okay. All right. So half QV. Q is the charge stored is 500 microcoulomb. Is the same for both. Okay, 500 microcoulomb. All right, microcoulomb. Then voltage is 10 volt. Voltage is 10 volt. So let's calculate 500 microcoulomb. 500 microcoulomb. So 500 multiply 10 divided by 2. So okay. So okay, this micro here is exponent. Exponent -6. Don't forget to change to SI unit. Yeah, don't forget to change to SI unit. So 500 multiply 10 divided by 2. So I got 2500 exponent negative 6 joule. Okay, so it is 2.5 exponent negative 3 joule. All right. Yeah. Okay, good. So now how about the U2? U2, okay, the charge stored is remain constant, 500 microcoulomb, but the voltage voltage has dropped. Voltage has dropped from 10 to 2.5. Okay, so put it 2.5 volt here. Okay, 2.5 volt here. So 500 multiply 2.5 divide by 2. So it's 625 micro is exponent negative 6, exponent negative 6, and then so this one is I can put it as 0. No, maybe I can put it as 6.25 exponent exponent 2, okay, negative 4 joule. So which one is higher? Which one is higher? Of course, the one with less negative exponent. Yeah, less negative. So this one is higher, U1. So I can put is U1 is higher than U2. You can write the value 2.5 exponent negative 3 joule is higher than U2. 6.25 exponent negative 4 joule. So the energy stored has decreased from U1 to U2. Decrease from this value to this value. So energy stored decrease. Energy stored in the capacitor has decreased after you insert the dielectric. It's decreased and has decreases after insert dielectric. Okay, after you insert dielectric, the energy stored in the capacitor decrease to 6.25 exponent negative 4 from 2.5 exponent negative 3. Yeah, the energy stored has decreased after you insert the dielectric. Okay, so that's the proof. Okay, so it's correct, the energy stored is decreased. So okay, that's the answer. Okay, so that's all for this question. See you again in the next video. Bye.